solve these equations that only had letters in them, which is every student's worst nightmare when they see it. But the point I tried to make was if you can solve equations, you can solve equations with no numbers in them. So 51, so here's the equation. Somebody have any idea what that equation is for? What that is the equation of? It looks like 1/2 height times the base, which would be the formula for a... Uh-oh, not a circle. There's no base in a circle. Triangle. So triangle, this would be height times base. So triangle would be half that, right? That's where the formula comes from, really. This looks like half height times the sum of two bases. So that would be a triangle that's been beheaded. So now it's got two bases. So this is the formula for the area of trapezoid. If anybody, even if you weren't interested, I don't care. That's the idea. Right? I'm not going to go. It's just to show you that these, do you have to know that to be able to do this problem? No. But I want you to realize, I think every single one of these, well, no. Let me take that back. Quite a few of these are actual formulas, standard formulas. Some of these are just letters they made up and threw it together for practice. But here I'm trying to solve for B. A. Okay, I'm looking at 52. It doesn't really matter. Do you guys understand? If I can solve for B, it's the same shit for A. It should almost be the exact same look. What's the worst? How do I say this? There's so many different ways to do this, but the very first thing I always do when I'm trying to solve an equation is I get rid of something, because they're normally students' worst thing next to word problems is what's kind of like the worst piece of this, besides the fact that it exists in the first place. The fraction, right? So in an equation, I want to kill my fractions because they're kind of make things gross. And I can do math really well, but even I am like, let me just kill those damn fractions because I'm human. And it's where humans are going to make mistakes, or fractions. So how do I kill that fraction? Multiply by 2, exactly. Because what's this fraction represent? Division by 2. So how do I undo that? Multiply by 2. Bam! So then I end up with 2 big ass A equals H times little a plus B. Now from here, there's 2 different ways you can go. What's kind of like in my way right now? I'm trying to solve for A. H is in my way. You see what I mean when I say that? Stupid H. So you could take care of it 2 different ways. You could either distribute, which is what a lot of us first think of, because that's a normal step in solving equations. But to be honest, you could also just divide it the hell out of the way, right?
You can.
So either way, of course you can. So that H is a problem. I can take care of it by distributing it because now I can move stuff around, get the A piece by itself. I can do normal stuff like I'm used to. So if we do it that way, that's the way I think most people would do it. What do I end up with on this side? Where's my A term? Ha. So what do I want to get rid of course, first? So if I had, for example, if I had 10 equals 3A plus 7, what would I do first? Subtract the 7 because I want to get the A piece by itself, right? This is what I want you to realize. You want to get the A piece by itself, so I need to get rid of this piece, of course, right? So how am I going to get rid of this piece? Right now it's adding HB, so I want to subtract HB. Do you guys see the way you have to think about the problem to work through it? You're not supposed to know exactly every step right when you start it. That's insanity. You do the first thing you think of, and then you step back and say, what can I do next? Well, I can distribute. Okay, good. I want to get the A piece by itself, so I'm going to get rid of this HB. Do you guys see how I made that? Do you see how this is the same? That's 10. I made that 10. I made this 3, and I made this 7. It's the same stupid equation. It's just that our brains like the numbers better. And you all just went -7, you automatically knew, but why did you say that? Because I want to get this piece with my variable in it alone. So I want to get this piece alone, I got to subtract HB. And then what's the last thing I have to do? Yeah, because what's the last thing I normally have to do? The last thing I normally have to do is divide by that stupid coefficient, right? Coefficients are all like down with Jeff. It's all stupid. So then divide by h, yeah. Now you could have divided by h right here, and that actually turns out being much easier. But a lot of students don't see that, and I don't blame you because we drill it in your head so hard that you have to distribute when you're solving equations, because normally you do have to. Okay, so divide by h and you're done. I like it. And what would really be amazing is if you guys were able to create your own little side equation here and just let your brain do the next step and go, whoa, what did I just do? Do the same thing to what I actually have. It's really a good way to kind of, because normally you're able to just automatically know what to do next in that problem. This problem is a little bit harder for some reason. It's because we're just not used to seeing something with almost no numbers in it, right? Cool. All right. Anything else from homework stuff? Did you have today?
36.
36, the same. Let me see. Oh yeah, this one's kind of gross just because of the big ass numbers they give us. This is the one about Greece, the population in Greece. I was all excited because they took the sound barriers down, but oh well. Let's see. Let's see. Oh, Greece and Belgium. Okay. So the population of Greece was 10,600,000 with a projection of a decrease of 28,000 per year. Belgium, 10,200,000 with an increase. Oh, there's a decrease, but just less of a decrease. A decrease of 12,000 per year. Yeah. When will the two countries have the same population? Now, why does it make sense they'll have the same? Greece starts with more, right? But of course, it makes sense that at some point they're going to have the same population because Greece is the word. Goes down more per year. So at some point, Greece's population is going to decrease enough to catch up with Belgium. Right, I guess I did that right for you guys. I like it. So this is related to something we're going to get into in chapter 3 is if I have two lines that have different slopes, they will intersect at some point. Right, to be parallel, they have to have the same slope. So these two have different slopes. Now, you might go, what the hell are you bringing lines into this shit for, Jeff? Because, well, I'll show you in a minute. You don't have to think of these as lines. You don't. But where's my variable go? What is my variable? What's the question? Yeah. When will the two countries have the same population? So this is both the year 2000. So what's my variable going to be? What's my variable going to represent? I don't want it to represent the year because then my equation gets a little gross. Maybe I want to let it represent the number of years after. After when? When was the initial population that talk about?
After 2000.
Oh, 2000. Okay. So this is the year 2000. So in the year 2001, how many people would be in Greece? What would you do? Subtract 28,000. In the year 2002, you would take 10,600,000 and subtract 28,000 twice. In 2003, it'd be 3 times, right? So in the year 2000X, right? 2000 whatever. So X years after 2000, what would the equation be? Well, you start with 10,600,000 and you subtract 28,000 per year. Yeah, and so what's the equation going to be for Belgium? It's going to be start at 10,200,000 and subtract 12,000 per year. Please see how that works. I mean, how did I figure this out? I said, okay, what would I do if it was 1 year later? I would subtract one of these. What if it was 2 years later? I would subtract two of these. What if it was X years later? I would freaking subtract X of these. That's the power of algebra. And I know students normally look at me when I say, whatever, man, make a little video, whatever, shit. The power of algebra. No, screw this. But I don't know, but I could just call it X, and then I could do shit with it. What do I want to be true about these two populations? This is the population of Greece any number of years after the year 2000. This is the population of Belgium any number of years after the year 2000, but I want these to be equal. And then I have an equation I can solve. Right? And if I were you, I would divide everything by 1,000 and make all the numbers smaller, but you don't have to if you don't realize that. Do you see what I'm saying? Everything is 1,000 times bigger than it really has to be. So one part of the things that get people thrown off here is the size of the numbers. Right? How you guys doing? I mean, you've got to stop and think to do these problems. There's no not necessarily okay, this is example 3, this is what I do. This is just like example 4, this is what I do. You can actually think physically, just like I did. After 1 year, what would happen? After 2 years, what would happen? And then it helps you set up the equation. I like it. So equations have meaning. Believe it or not. And since they have meaning, I can get meaningful results from working with them. Okay. Is that cool? Well, pretty much gets you almost there. Make sure you answer both questions, though. They say, what year and how many people will there be in both countries? Anything else from homework stuff?
60 for the same factor.
Oh, yeah. There's always the age problems are always the freakiest ones. Oh, yeah. A friend of mine could not understand why, if at one point you're twice as old as somebody, or 3 times as old as somebody, how can you be only twice as old if you wait a few years, So let's start with that. What if, now watch this, just to give you an idea of how this works. If somebody's 10 and somebody else is 30, this person is how many times older? 3 times older, right? This is 3 times that age, right? Now, in 10 years, how old will this person be? How old will this person be? Now, this person is only twice as old. Do you guys understand? Are you freaked out about that? I would hope to God you're not, because twice as old is a multiplier, and if I wait several years, that's an addition. Of course, they don't have to be consistently the same, because one is multiplying and one is adding. Holy shit, of course they don't have to be always the same. You're still 20 years apart, right? But that 20-year difference means less and less as everybody gets older. Right here, it means a lot. Holy shit. Right? Trouble. And then here, no problem. Okay, I kind of went a little too far and found controversy, but screw it. Are you guys with me on that? So this problem says, there's an elderly uncle married a woman when he's 3 times her age, but in 20 years I'll only be twice your age. Okay, so the whole point, the first place, huh? This is 60, right? This is the one, who asked me? You did. You did. You didn't. Who just asked me about number 60? Or am I?
Oh no, I asked about 60. Yeah.
60, okay. Thank you. I can't be sure about anything. I could be hallucinating this whole morning.
We're not here, Kathy.
Yeah. So what's my unknown going to be? Their ages. Okay, so uncle age and the woman's age. All right, now look at the very first relationship between the two. Marrying a woman when he is 3 times her age. So which one is going to be just X?
It's the woman.
Good. Why? Yeah, so if the woman is X, the uncle is 3X. I got to know the woman's age first because the uncle's age is 3 times that. I got to do something to the woman's age to get an expression for the uncle's age. Let that step be easy. That step is the most important step. Which piece is just X? Why is that the most important step? Because everything else is built off of that. But it's not a hard step. It really shouldn't be. Which one does the other stuff depend on? Now, in 20 years, I will be twice her age. This is where the formula comes from. So in 20 years, how old will each of them be? In 20 years, right now the uncle is 3x years old. So in 20 years, then he'll be 3x plus 20. Yeah, that's up. If I'm 15 now, in 20 years I'll be 35. So I add 20. Right? So 3x plus 20. And then amazingly enough, the woman will be how old? X plus 20. Now I'll tell you what. I'm not going to do any more of that problem. Because right now they say, I, the uncle, will be twice her age. The uncle will be equals twice her age. You should be able to set that formula up and do it. So do these come into play directly anywhere? No. That's what they are now. The whole equation is all about what's happening in 20 years. He will be twice her age. Then you can figure out what X is. How are we doing? So there's all kinds of stupid jokes related to this kind of thing happening. How long until we're the same age? Oh, God. All right, sorry. They're out there. All right, anything else from homework stuff? That problem, wherever it says critical thinking exercises, that's supposed to be a slightly more difficult problem. So if those are the only ones you're having trouble with, you're doing great. And you're all like, dude, I'm having trouble with some other stuff. Okay, then ask me. Okay. So let's do this. Let's, yeah, I like it. You would, Jeff. Let's have a quiz tomorrow. Oh, welcome back. Quiz tomorrow in section 2:1 through 2:3. I'll just have one word problem. Okay, and it's not going to be one like that age problem. Right? If I ever gave you one like that, it would be a bonus question, really. 2:1 through 2:3. Quiz tomorrow. Okay. So we got up through 2:4 before the break. So today we're going to do 2:6. It's amazing. 2:5 is not part of our curriculum. So we're not going to do it. I didn't talk yet to you guys about inequalities, have I? Huh? A heavy topic? All right. One thing I disagree with, but I'm going to do anyway, is the way the book represents
I'll do what I want.
closed circle, open circle instead of brackets and stuff. Because this book does not go into interval notation, I don't think. No. Did anything of what I just said make any sense?
No.
Interval notation. How many of you guys ever heard of interval notation? Anybody? Okay. All right. You won't hear about it from me then. I'll be all right. But let's see how much you guys know about solving inequalities already. The great thing about solving inequalities is there's only one place, really, where there's a difference between solving equations and solving inequalities. So if I said, x plus 1 has to be less than 7. So that's officially an inequality because it's not equal to 7. It has to be less than 7. So how do you solve that? That's crazy. So everything's the same. Everything for solving these, everything's the same except for one thing. So we'll get into that one thing in a minute. Minus 1, minus 1. X less than 6. How do I graph this? Oh, shit. Well, how many variables are there?
You only switch the sign when it's like multiplying.
All right, that's what we're going to get into. That's the one place, exactly. Multiply, divide, negative. We'll get into y. There's only one variable here, right? I don't see a y. I don't see a z. I don't see a w. So I'm going to use one number line, right? In chapter 3, we're going to get into like x plus y equals 2.
Right.
And then we're going to have, of course, 2 axes for both variables, right? Oh, shit. Less than 6, so 0, 1, 2, 3, 4, 5, 6. What do I put on the 6? Does anybody remember? Or do you guys have done this at some point, right? Yeah, I don't want to include the 6. Which way am I going to shade? Yeah, you got to love it. If you have the variable on this side, that's an arrow pointing you in the direction. Also, you can check, is 0 less than 6? Yes, I'm going to shade that way, because that must be where the answers are, right? But even better is that's an arrow pointing you in the direction to shade if the variable is on that side. So this will be an open circle. Why is that an open circle? Because I only want to shade where there are answers. And is 6 an answer?
No.
Is that a dog? What is that? Did you guys hear that? Or is it just me?
I think someone was hungry.
Oh, okay. It's not like a dog. Sorry if that was one of you. It's not a callback to like American Idol. Yes?
Could you do the brackets like the two brackets if that's how you
Remember, so the whole thing with the bracket and the parenthesis, the bracket, I always teach that it looks like part of an I for include. And the parenthesis looks like a part of an open circle. So here I would use a parenthesis. Yeah.
that's
So if you do that, that would be awesome. If you're used to using parentheses and brackets, use them all day long. I love it. If you don't want to, or if you've never seen it before, or if you like the fact that you don't have to use them now, don't. You can use the open closed circle because the book does. That relates more to interval notation. So just to show you, you don't have to do this. Just to see if you guys remember now, what's the largest my answer can be? Almost up to 6. And what's the smallest it could be? Negative infinity. So if you've ever seen something like that, that's interval notation. From negative infinity up to 6. Not including 6. You don't have to know that for this class. So if you just I wanted to see if I see any looks of recognition, and I don't. So it's like...
Yes.
Let's see, what else do they want you to do with this stuff? Blah, 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 blah. I think that's it with the working it out. So let's see, the one place where this is different, the one place where something else happens is related to this. And remember, what are variables? What are variables? What's x mean? It's a number. So whatever numbers do, variables also have to do because variables are freaking numbers. So, for example, which one of these is bigger?
2.
That's crazy, right? Now, if I multiply or divide both sides of this by negative 1, what happens to both sides? So if I multiply or divide by negative 1, what happens to this side? It becomes negative 2. What happens to that side? It becomes... Which one's bigger now? So the sign flips. Because when I multiply or divide by negative 1, I change the side of the 0 that I'm on. So of course, which one's bigger now is changed. So what the shit does that have to do with me doing these problems? Well, if I have this problem, let's just cut to the chase. I work a problem out and I get to here. What do I have to do to solve that? Divide by negative 1. So I get x less than or equal to negative 4. Why? I love this. Why? Because. Ah. Because. I mean, that's the most... I don't have to explain because that's just how freaking numbers work. Right? So that's the one time I can just go, because. That's how numbers work. I can't explain it anymore because that's the base explanation. Right? You just have to remember, when do I flip the sign? It's when I divide or multiply by a negative. Now, real quick, let's check. Give me one number that works. Let's not even graph the damn thing. Just give me a number that's an answer. Ooh.
-4.
Yeah, -4 is an answer. And let's check it. Does that work in the original? Is -4, is that greater or equal to 4?
Yeah.
Yes, 4 is greater or equal to 4. Give me another answer that's possible here.
-3.
Less than or equal to -4.
Oh.
No, less than or equal to -4.
Oh.
Which means if I want to be less than a negative number, I have to be even more negative. Let's start there. All right, let's take a step back. When we're dealing with inequalities, it's important to know what's bigger, what's smaller in the first place. Any number that's to this way of another number is bigger. Any number that's this way of another number is smaller. So people get a little confused about which one's bigger, -10 or -9. Well, people say, well, 9's less than 10, so -10 is bigger than 9. No, it's not. It's smaller because it's that side. You guys with me? Smaller should be the place I don't want to be. Like if I think about money, I want to be in the greater place, right? So do you want to owe somebody $10 or do you want to owe somebody $9 if that's the only options you have? I'd rather owe them $9. Some of you guys know, I like round numbers. No. So that must mean that -10 is less than -9. That's a better place to be. Right? So less is that way. Greater is that way. Period. Is that cool? So what is less than or equal to -4? Like, for example, -5, -6, -7. Because that's all in that direction of -4, isn't it? So if x is -5, does it work in the original part? -5, is that greater or equal to 4? What's -5? 5. That is bigger than or equal to 4. Check. So if you didn't flip the sign, you would get a bunch of wrong answers. You would just get one right answer at -4. All your other answers would be wrong. Infinitely wrong answers. That sounds bad. You guys, I know some of you guys remember you flipped the sign. But my hope is that example I gave with the 2 and the -1, that's the only explanation you need for why it happens. Because it happens. You change the side you're on. So of course the greater and less than is going to be different. Because what's greater or less than depends on what side you're on. Okay, I like it. So here, you guys solve this. And then graph it. Stay with me. I think my cold meds are really kicking in right now. Solve and graph this here. Oh, what you got, Jeff? Let's do, sure. Do that one, and then do this one.